Okay, Stephen, it's real easy. Wherever, if I'm writing on that board, you're filming. If I'm writing on that board, you turn it. That's it. We don't ever have to do that. We don't ever have to do that. Nobody wants any of that. They want all of that. All right, my turn. I don't know about anybody else. I am so over the moon excited about working with the 11 of you. Yesterday, I don't know, Ms. Fain, if this happened to you because you've been teaching for so long, I got sick to my stomach. I was so excited. All I could think is I just want to throw up. I'm so excited. Like, my just right job is being in the classroom with high school students, making you miserable for 180 days out of the year. Wait, did I say making you miserable? No, like growing you, pushing you, working you harder than you have ever worked before. This is why you chose Calculus BC. This is by far the most demanding math course that is being offered here at Southwest or there at North Central. My 5 trailblazers on the other end of the camera. We're going to spend a lot of time together this year. So I'm really collectively teaching 16 of you right now. There's 5 trailblazers. Everybody say hi to the trailblazers.
Hi.
Yeah. Okay.
Is it live?
It's not live. Okay, it's not that high quality. But I'm gonna like post this later, and they're gonna experience Calc BC in like a flipped classroom experience. They're gonna watch the videos at night, and then in class they're gonna like work together on the stuff.
I would want to do
Okay, so there's collectively 16 of you that I am responsible for right now. Everybody good?
Yeah.
All right. So when you walked in, you picked up 3 things. You picked up a syllabus. Find the syllabus, please. Okay, I'll give you a hint. It says syllabus at the top. Every single thing you are going to pick up from me will have AP Calculus ABBC on it. If it doesn't have ABBC on it, you picked up the wrong thing. There is a 1 with a line through that. Why a 1 with a line through that?
Could it maybe for both?
Huh?
Could it maybe for both calculus, A, B, and B?
Oh, no.
No, it's not.
I'm crossing out the 1. No 1s because
This is a food class.
this is an AP class. The AP exam that you're going to take in like 100 and I forget to count days, okay, or it's actually like 200 and I forget to count days, is scored on a 1, 2, 3, 4, 5. There will be no 1s, okay? The 5 is because we are all going for a 5. Like that excites you, that drives you, this is your goal. If you're like, no, it's actually not my goal, shh, don't tell me. It's your goal. We're going for 11 5s. And if one of you could get a 6, that would be even better.
16?
A 60?
16, 5.
6, thank you, 16 5s. I care about you all too. All right, now we're not going to go all the way through the syllabus because you know what? When are you going to go over the syllabus?
At home.
Tonight, at home. Here's what I want you to know about the syllabus. I love being a math teacher. Like if God came down and said I could do anything for the rest of my life,
All right.
this, for real, like this is it. This is the thing I wanted to do when I was in high school. This is the thing I get to do every single day. That's why I was sick to my stomach last night, because I set the bar so high for myself and for you all. And it's going to be a great experience for all 16 of us. All right. So tonight, read the syllabus. A couple of things I really want to call attention to. Top of page 2, you're going to have to go fast. I'm going fast.
Okay.
My information's at the top there. I'd recommend putting my cell phone number in your cell phone. Not just so that I can look cool, but like part of my job, I'm going to be teaching at Northside. I'm going to be working at other campuses with other teachers. I'm not going to be as available after school for tutorials as I would like to be, but I promise you this, if you call me or send me a text, I will respond. Okay? I will respond before I go to bed, and I'll be like, hey, let me help you out. If for some reason I don't get back to you, we'll figure it out. Email also works really, really well for me. Everybody okay? All right. Yeah.
Is this where you live?
Is that where, yes, that's my address, 5150 Grape Street,
I gotta go
Give us your
stalk you.
so that you guys can come on over and do yard work. No. All right. Class guidelines. I can sum it up this way. Be at your best at all times. Okay, but there's like more specific stuff in here. Calculators, you need to have a graphing calculator with you every single day starting tomorrow. Based on my conversations with you all at the end of last year, everybody has a TI Inspire.
Yes.
So I'm only going to speak TI Inspire. Trailblazers, I hope y'all have TI Inspires. You need to have that with you every single day. You also need to have a math binder with you every single day. I'm going to give you a lot of handouts. I don't want them, I don't want them to die in the bottom of your backpack. Get a binder. Okay? Now, we're not going to go all 6th grade, like everyone has to have a red binder and it has to have 5 sections. Get a binder. Every paper I give to you will be hole punched. I go circus boy crazy when teachers are like, kids need to have a binder, and then they don't take the time to do the hole punch. Everything's going to be hole punched. Okay? There's going to be problem sets and homework. You're going to read more about that later. There's going to be some safety nets, like there's a YouTube channel of every video that I've created. If you're absent someday, I'm going to email you and be like, hey, the video's been posted. Go. All right. Other than that, there's not really much else I need you to worry about. Bottom of page 6, I need you between now and Wednesday morning to get this signing that you've like read through it all. Mom and Dad have read over it. If they have any questions, they can call me. Okay, Trailblazers, talk to Mr. Semler. We good with the syllabus? I can put it away. All right. The other thing that you picked up when you walked in, you may think you picked up 4 or 5 copies. No, it's 1. It is 58 pages. My bad, 59 pages. This is everything that we're going to do between today and tomorrow. No. So you're like, okay. So flip over to page 2. This is everything we're going to do between now and Wednesday, August 31st.
Are we going to get one every month?
Not every month, but every unit. If you look on pages 3 and 4, all the definitions for all the vocab that we're going to be talking about. I'm not just going to expect that you looked at this once and you know it, but I wanted you to have the vocab in one nice place. I tried. Okay, we can thank Miss Blakely at East End. It was her idea, and Miss Cooper at Southeast. Pages 4 and 5, these are all like the skills, all the things you will know by the end of the first unit. I bet, because you're all so wicked smart, that a lot of these things you already know because you were well prepared in pre-calculus last year. But I wanted you to have all these things there. Everybody still good? Okay, no one's crying on me yet. Okay, let's talk about the summer assignments. Here's some start. Okay, summer assignment. I have no doubt that the 11 of you did it wonderfully, did it to the best of your ability, and you are feeling proud of the work that you did. No one did it last night or this weekend, because that would be foolish, because I would know as soon as I look at your paper. I am going to pick up round 1 and round 2 of the summer assignment tomorrow when you walk in. Now don't be like, oh thank God, because you're ratting yourself out. If you did not do this assignment well over the course of the summer, take care of that tonight. Give yourself one last push. Maybe you want to look over this and be like, hey, there is this thing I didn't completely understand. Call one of the other smart people in the room. Round 1 and round 2 are due tomorrow. Pretty clear? Round 3 is due Friday. Round 3 had all the limits and all the derivative stuff. That's actually stuff we're going to work on this week. Round 3 is due Friday. Yep.
When we're doing the work, can we bring in our summer assignments and like use that review?
Can you ask me that question one more time?
Like,
I think my answer is yes. I want to make sure I understand
like you
your
said,
question.
we're doing derivative stuff this week. And so
We're
can I
probably
bring-
not going to get to derivative stuff this week,
We're
unfortunately.
doing like limits and stuff, right?
We are doing limits all the time.
So can I use like my round 3 work as like a review thing?
Of course.
Okay.
Of course. Thank you for asking that. Everybody good?
Mm-hmm.
All right. Do you guys have any questions for me? Anybody scared?
A little.
A little nervous?
Yeah.
Considering that you are in the most demanding math course offered at Yes Prep, I think it's fair. It's okay. I will tell you though, I take really good care of the teenagers in my life. Okay? And the 12-year-old who's at home right now. All right.
Wasn't that bad, though.
What else? All right, so we're going to do a little bit of stuff that you are really comfortable with, and at least one thing today that no lie, that I am not super comfortable with, and I practiced this morning. Okay, we're going to skip past the do first. This is the same packet that the AB students and the BC students are getting. I'm going to skip the do first. I'm going to assume that you know how to put all those numbers in order correctly. Okay? So, take a little bit, read through this table. Make sure that you are comfortable with the notation, how to read it, and what it means, and we'll talk in a bit.
Here.
Did I say it right this time?
Yeah.
Andrew.
Here.
Andrew. Celeste. Aaron. Giselle. Lewis. Steven. I know Steven. It's like Steven Spielberg. Oh, it works. You were born for this job, Steven.
I was.
Google Steven Spielberg later. Carmen. Halimon. Oh, I've known you forever. Myra. David. Where's my David? All right, 2, 4, 6, 8, 11. Okay, 11 good looking people. 12 with me. All right. Notation, is everybody okay?
Oh, yes.
Like, we're good with this? Now, here's the thing. When I ask you something like, well, I won't even say it yet. Carmen, can you read this for me using your best mathematical notation?
The limit of x squared
There you go, the limit of x squared.
as x approaches 2.
The limit of x squared as x approaches 2 from the left. Everybody okay?
Yeah.
Another way to say it, limit as x approaches 2 from the left of x squared. We're going to be okay with that. Okay? But what's the question? This is what I care about. What's the question I'm asking with this notation? Aaron.
What happens to the range of values on the graph x squared
Yep.
as the domain values approach approach 2 from the left?
God, I could not have said it better myself. It's like you were reading from a script. It was so perfect.
Weird.
Okay? Right. We're saying for the function x squared, what happens? What happens as the x values get closer and closer and closer to 2? You guys know the answer. What happens? What happens to the y values? The x values get closer to 2. The y values get closer to 4. Not infinity.
Oh, not yet.
Not yet. Infinities are coming. The x values get close to 2. Do they actually get to 2?
No.
No. Give me an example of getting close to 2 from the left.
Oh, the limit as
Give me an example. Give me an example of a number to the left of 2.
oh no, just kidding. 1.9.
Yeah, you're like, grrr. Limit as x approaches 2 from the left, 1.9. Can you get me closer?
1.99.
1.99. Can you get me closer? Can you get me closer? 1.9, right? And then I could ask any of the boys, and they're going to go obnoxious, and they're going to be like 1.999999999, and it keeps on going forever, right? If I take something super close to 2 and I square it, my answer is going to be 4, right?
Yeah.
Exactly 4?
No.
No. That's the thing with limits. I don't get to 2, I get close to 2. How close?
Really close.
Like wicked close, awkward close, prom date close, okay? So close to 2 that I'm like, hey, let me just plug in 2 and see what happens. I'm going to get close to 4. We're good? All right, so let's look at this little diagram over here. I want to find the limit as x approaches c from the, which side? Left. What happens to the graph? What happens to those y values? Aaron said it so well. If here's c and I get closer and closer and closer and closer to c from the left, what happens to the y values?
They approach L.
They approach. God, I love it. You said it perfectly. They are getting closer to L. Are we okay? Like I'm here, I check out the y value. Get closer, check out the y value. Get closer, check out the y value. I get close to L. Well, what if I said the limit as x approaches c from the right-hand side? You guys would all tell me? Still getting close to c, but now I'm coming in from the right. What's happening to those y values? Get close to L. And what if I just said, Polymon, what's the limit as x approaches c of f of x, and I don't put the little plus or minus sign?
It wouldn't be undefined.
It would be undefined?
Yes.
No,
No.
Go for it, Aaron.
they're both approaching L, so then we're still
Yeah.
L.
Right, the limit from the left is L, the limit from the right is L, and the thing that you guys remember from pre-calculus is? It's going to have to be L. When we say, and here's the part that should be comfortable from pre-calculus, when we say that the limit as x approaches c is equal to L, what we're saying is if I get closer from both sides, the y values all get closer to L. We're okay? Anybody bothered by the hole in the graph?
No.
No, because we care about close, but we don't get there. You just get close. All right, so Lewis, right? No.
It's David.
David.
David, I'm so sorry. David, okay. Can you read this part? This is like the new College Board definition of limit. Go for it, David.
Given a function f, the limit of f of x as x approaches c is a real number L if f of x can be made arbitrarily
Arbitrarily, yep.
close to L by taking x sufficiently close to c, but not equal to c. If the limit exists and is a real number, the common notation is limit of f of x as x approaches c is L.
Okay, David, well done. That did not flow, right? It didn't just like roll off the tongue. It didn't do that for me either, which is why I was like, oh, I'll just sacrifice one of you and me. Okay? This is like their more specific vocabulary definition. Like when you take an advanced analysis course, like Mr. Link and I have taken, like this is your working definition of limit. But is everybody okay? You already know what it means. As I get closer to C, the y values get closer to L. Here's what they're saying. Given a function f, the limit of f of x as x approaches c is a real number L. You can also input here like finite, meaning not positive infinity or negative infinity. The limit is this finite number if f of x can be made arbitrarily close to L. Here's where L is. What we're going to do is we're going to pick this little bubble, this little interval around L. And you might say, well, how big is the interval? As big or as small as you want it. But what we're going to say is no matter how small that interval is, you make it teeny tiny. Oh, no, teeny tiny. No matter how close you get to L, when you map those values back onto the function, there will be an interval on the x-axis such that if I pick any value of x in here and I plug it into the function, the answers are always going to be in this little interval over here. I think this is a really big, sophisticated idea that I don't want anybody to freak out over yet. We're okay? But the idea, like the real thing, the epsilon delta definition that we would have learned back in like the day, is you look at the output and you say that's the limit if I can pick a super tiny interval, and on the x-axis I can find a small interval around C, and every single number I pick in here will land over here. The y value will be in that tiny interval. That's like the technical definition. Think about it later, but not too terribly much. All right, so if you guys go over to the top of page 8, you get an opportunity for you guys to like get up off your feet. And you're going to do what I like to call some power teaching. Yes, it's going to be a little bit awkward. You guys are going to want to have page 8 out in front of you. And I need you guys to get up on your feet. It's okay. No one's going to see this video except the 5 friends at North Central and like the world, because my videos are public. Okay? All right. So, if I asked any of the good-looking friends in the room for this graph, what's f of 3?
-2.
F of 3 is -2. Does everybody agree?
Yeah.
Okay. But if I said, what's the limit as x approaches 3, everyone would tell me? 3. Here I'm asking, what is the exact value at 3? Here I'm asking, what happens as I get close, but I don't get to 3. Okay, so here comes power teaching opportunity number 1. Power teaching just means I'm going to say something, there's going to be some hand motions, you're going to repeat it after me. And you're going to look awkward in the process. It's okay. It's okay. In order for a limit to exist, the limit from the left and the limit from the right must be equal to each other. A hole in the graph is okay, but jumps, breaks, and vertical asymptotes are not. Okay? One more time. In order for a limit to exist, what has to be true? The limit from the left and the limit from the right
Must be equal.
must, like, I want like intertwined fingers here. They have to be equal to each other. A hole in the graph is okay. Why is a hole in the graph okay?
Because we never plug in the actual value.
You don't actually get to the value you say when you get close. So in order for a limit to exist, the limit from the left, limit from the right have to be equal to each other, and a hole in the graph is okay. But how do we feel about jumps? If the graph looks like this, would the limit exist?
No.
No. What else would be a problem for us? No breaks. And you were waiting for it, and no vertical asymptotes. Okay, turn to your neighbor, teach him real quick.
Probably the same thing.
Those are okay.
Those are okay.
Holes are okay. Breaks are not.
No, jumps.
In order for a limit to exist, the limit from the left and the limit from the right must be equal to each other. A hole in the graph is okay, but jumps and breaks and vertical asymptotes are not. All right, nice job. Have a seat.
What happened?
Steven, nice job. That you get some awkward vertical asymptote happening here. You were late. Vertical asymptote, not penguins. Okay. Now here's a place where we're going to have some difficulty. I was raised in a world where if I asked you guys for this graph over here, what's the limit as x approaches -4 from the left? Look at the graph. What's happening?
It's going up. It's increasing.
Vertical.
Here's -4. If I approach -4 from the left, what's happening to those range values? They seem to be approaching infinity, right? I want to say positive infinity because that's how I was raised. And if I then said, what's the limit as x approaches -4 from the right?
Negative.
Negative infinity. But here's how we're going to write these, at least for a little while. We're going to say the limit does not exist because of unbounded behavior. This is also being very technical right now. The College Board is really a big fan of limits exist when they are finite numbers. Numbers like 12, -7, positive 119. We don't like answers of infinity and negative infinity when it comes to limits. Okay? Okay. But here's the good news. If I asked one of you what's the limit as x approaches -4 from the left and you said infinity, that's okay. The better answer is going to be does not exist because of unbounded behavior. The graph is just heading up towards infinity or heading down towards negative infinity. That's the best answer. Okay? All right, one last thing that happens, and this is another case of limits that don't exist. Let's look at this last one, this indecisive limit. If I asked you all, what's the limit as x approaches 0 for this graph? Take a look at that and decide. What's your answer going to be? What happens as x approaches 0? We're getting close to 0, right? Now I hope all 11 of you, 16 of you said, wait a minute, he said limit as x approaches 0. Which side?
Both sides.
Both sides. So you checked. What happens limit as x approaches 0 from the left? What happens as I approach 0 from the right? And in both cases, we're going to get 0. Good. What's the limit as x approaches infinity, though?
Unbounded behavior, isn't it? Or is it negative?
D
It's even worse.
and E because of oscillation.
Okay, D and E because of oscillation. What happens? Look at this graph. This graph just kind of keeps bouncing. It's like the sine graph, except the sine graph is always trapped. This guy here decreases, then it increases and decreases. Is it ever getting closer to one number?
No.
No. So that's when we're going to say does not exist because of oscillation. O-S-C-I-L-L-A-T-I-O-N. Oscillation. Here's the mistake that teenagers make all the time. As soon as they see a graph that does this, they're like, limit doesn't exist. Oscillation, we normally are talking about the ends. Like if I head off towards negative infinity or positive infinity. Over here, you're getting closer to 0. The graph isn't oscillating as you get closer to 0. It's getting closer to 0. Pretty good? We're good? Nice. All right, so let me stop talking. I want to give you guys some practice time. There are a bunch of problems on page 9. I know we're going kind of slow right now. Please forgive me. We'll go faster. Now some of you are like, no. Yes. All right, you can work with anyone that you would like. There are 12 problems here. There's no way you're going to get through all 12. That's okay. Just go as far as you can in the next 5 minutes. Is it still recording? Is it still recording?
Yeah, that's right.
Perfect.
So these both the same.
So limit as x approaches 0 from the left.
They're both kind of doing the same thing.
Yeah.
Is it both because of this?
Mm-hmm.
Okay.
Now here's, I want you to be careful.
Okay.
Don't abbreviate.
Oh, okay.
There are legal abbreviations, and I promise I will teach you all of them.
Mm-hmm.
UB doesn't mean anything to me.
That's correct.
Thank you for asking. Okay, so limit as x approaches 0 from the left. Oh, no, you're totally right. I'm so sorry. Wait, where's 0?
I thought it was it.
Ah, I gotcha. Yeah, so limit as x approaches 0 from the left is 1. Limit as x approaches 0 from the right is 0. Okay. And limit as x approaches 0 is... Why?
Because these are unequal. They must be equal for.
Right, but what I need you to write though is you're going to say does not exist because the limit from the left and the limit from the right are not equal to each other. And I need to come back to Aaron because...
Yeah, I was like, he just told me. He was like, yo, he was like,
I did the same thing.
Thank you. Thank you. Oh, I don't want you to
So
touch me.
these pertain, these two pertain to all.
Yeah, here's the 0.
Yeah, these two pertain.
Sorry, the scale's tough to read. Here, you can touch me if you want to. You doing okay?
This is,
That's the 0, yeah.
They're doing this. Okay.
Sorry, yeah, we're having some, the scale is hard to read
So
issues.
wouldn't the limit be
Friends over here.
one?
Two.
This one.
So because it's supposed
It's gonna be a whole.
Okay.
So they're undefined. Yeah, undefined. not actual like.
Man, this air freshener I bought is smelling good. It's not my cologne. All right, I saw just about all the papers. Limit as x approaches 0 from the left of h of x is
One.
1.
Isn't it? Yeah.
And limit as x approaches 0?
Zero.
Okay, yeah.
0. Now here's what I'm seeing on most papers. Limit as x approaches 0 of h of x is
Does not exist.
does not exist. Does not exist is never going to be a good enough answer. It's always going to be does not exist because. Because of something. Why does the limit not exist? Yes, sir.
The limits from both sides are not
It's a
equal.
jump.
Remember, in order for a limit to exist, the limit from the left and the limit from the right have to be equal to each other. You've got to jump. We don't like jumps, but I need to see it. Does not exist because the limit as x approaches 0 from the left is not equal to the limit as x approaches 0 from the right. Okay. How are we feeling about number 6? Limit as x approaches 3 from the left. Is that number 6? Limit as x approaches 3 from the left.
Does not exist.
Does not exist because-
Unbounded.
Does not exist because of unbounded behavior. The other thing that is actually an acceptable answer is limit as x approaches 3 from the left.
Oh, positive.
Is it positive infinity? Right. Positive infinity is the way that I was raised, but the College Board, they are really pushing, and rightfully so, does not exist because of unbounded behavior.
Is one answer more right than the other?
They are both
Yeah.
going to be considered acceptable. You will never see both on like multiple choice. You're never going to have to choose between the two. What's most likely going to happen moving forward, like on your exam, that's going to be the answer choice that you'd have to pick.
Mm-hmm.
Okay?
Yeah.
Was this pretty comfortable for all the friends?
Pretty much.
Okay, good. Trust me, I'm going to rock your world soon. The first day, 2 days, comfortable and easy. After that, hair starts to fall out.
That's a different one.
Error starting.
See y'all later.
Okay, real quick,
Hit me.
for number 5,
Yep.